Hello.
Hello.
Okay, so today we will proceed to chapter input-output facilities. Okay, so the name is lecture 5, but this is actually not, should not, I mean, it should not be teach on week 5 lah. It's just the name saja lain-lain. Okay, so in this chapter, we will learn about input-output facilities. Before that, I need to record our meeting first. I actually just asked for past year exam questions from the CC, and then they just give me lah. So later, after I studied that past year questions, then we will discuss that past year questions lah. For you all to prepare for your exam later.
Okay.
Because I'm afraid that that's why I asked them the past year questions earlier, because it is for us to prepare lah, to see what form of the questions for your final FOA lah. Okay, so and this chapter is actually, it's quite theoretical, and there's no Mr. Bharat Acharya for today lecture, because I didn't subscribe for the topics for the input-output facilities, because it is under another package. So I didn't subscribe that yet, actually. Maybe later lah. But for now, we will solely depends on the lecture slide that is provided by our course coordinator. Okay, so the input-output facilities. This is the chapter where we will learn about the I/O modules. The I/O modules is like the middleman between the CPU and then the peripheral devices, or the input-output devices that is connected to our computer. Okay, so he is like the middleman lah, that will interact with CPU, and then it also will interact with the I/O device or the peripheral devices. After that, we will learn about the three technique of how the communications between CPU and the peripherals. So there are three technique actually, which is the program I/O, interrupts driven I/O, and then the DMA, which is the direct memory access. So remember, there are three types of technique of how input-output devices or peripherals communicated with the CPU. After that, we will learn some of the input-output system architecture lah. And if we have time, we will continue to this lah today. But if not, then we will continue next week. Okay, so the first topic is the I/O module, which I said just now. He is like it is like the middleman lah between the I/O device and the CPU. Okay, so it's most simple input-output communication is using only one CPU, one I/O device, and one I/O module. This is the simple I/O configurations. And then it is usually used by simple devices like maybe remote. Okay, so I/O module serve as interface between the CPU and the specific devices. It accepts the commands from the CPU on one side and controlling the device on the other side. Okay, so it accepts the commands from CPU and controlling the I/O device. That is its first responsibility. Okay, so this is the more complex configurations of I/O module. It is a little bit complex lah from the previous, where where each of the I/O module it will connected to to one pair of registers in CPU, which is the pair of the register is the I/O data register and then the I/O address register. So each of these I/O module will connected to this pair lah, one pair of register in the CPU, and then this I/O module will serve one I/O device. Okay, so this is the another more details about what is the responsibility of the I/O modules. So this is its functions lah. Okay, so first it recognizes the message addressed to it and accept commands from the CPU. After that, it provides a buffer. Buffer is where the data from memory can be held until it can be transferred to the disk. Okay, so I/O modules, it provide a part of the I/O modules have some part of it that will hold the data from the memory. Okay, so until the data will be transferred to the disk, it hold it lah. Okay, so after that, it also provide the necessary registers and controls to perform a direct memory transfer. After that, these I/O modules component also have the interrupt capability. The interrupt capability is a part of the I/O module that can notify the CPU when the operation is completed. Okay, so this is also another functions of I/O module, which is like um, previously it is as the CPU interface. Okay, so this I/O module is as the CPU interface, which perform the CPU interfacing task. So what is the CPU interfacing task? Is accepting I/O commands from the CPU and then also sending interrupts and status information to the CPU. Okay, so that is the CPU interfacing task. This two is the CPU interfacing task. Besides that, it also act as the device interface. Okay, so the I/O module act as the device interface to the I/O devices. Okay, so one of it task is to move the head to the correct track in a disk drive and rewinding tab. So if uh, if we are using the HDD, so this is what the I/O module can do lah. It moves the head of the correct track in the disk drive and then rewinding the tab. Okay, remember in the HDD, it's like a CD kan inside the HDD. So in the HDD, it has a head to point at the right track lah. Okay, so I/O module responsible to move the head of the HDD to correct track in the disk drive. After that, the I/O modules also accept I/O requests and interact directly with the device to satisfy those requests. And then it would be difficult to program a CPU to provide a correct type of signal to operate the I/O device. Okay, so the CPU times required to control these devices, and it would reduce the usefulness of the system. Okay, so because of this problem, that's why I/O modules has these simple CPU I/O instructions. So the I/O modules can be used to control the complex operations. Okay, so these CPU I/O instructions simplify the task of interfacing peripheral devices to a CPU. Okay, so this CPU I/O instructions can uh, can lift up the considerable amount of work from the CPU, meaning dia boleh tolong banyak the CPU lah. Okay, so it also make it possible to control I/O input output to a peripheral with a few simple I/O commands. And these I/O modules also support DMA, which is the direct memory access, meaning it can direct access the memory without without go through the CPU. Okay, so it makes the CPU free to perform the other tasks. Okay, so the I/O modules also provide the specialized circuitry to interface different types of peripherals. Okay, so we proceed to the input output technique, which I said just now. There are three, which is the program, I/O, interrupt driven I/O, and then the DMF. All of this input output technique I used to communicate or exchange info between the CPU and the input output devices or peripherals devices. Okay, so like I said just now lah, there are three techniques of how the CPU and input output can exchange data or communicate to each other. Okay, so first is the program I/O lah. This program I/O, this is the technique where the CPU need to control the input output devices, and then for the interrupt driven I/O, it enable the external input control the process between CPU and the input output devices. For example, like our keyboard, our mouse. Okay, when it means that the external peripherals tu yang akan control the process between CPU and the peripherals lah. After that, we have the direct memory access, which is DMA. Okay, so this DMA is actually a method for transferring data between main memory and devices by that bypasses the CPU. Okay, so the first technique is the program I/O. Okay, so it is the simplest it is the simplest method for performing input output process. Okay, so an I/O module is connected to a pair of input-output register in CPU via a bus. Okay, so as you can see here, the input-output module is connected to a pair of registers, which is the data register and address register via a bus. Okay, there are two buses included here, which is the data bus and then the address bus. Okay, so this is the architecture of program I/O. Okay, so the process is when the CPU receives the input from I/O module. So this is what happened. The I/O module will send one instruction to the CPU. The instructions is like one word at a time. One word meaning 16 bit at the time. So it send the instruction to the CPU. And then in the CPU, the first register that will receive that instruction is the I/O data register. And then the I/O data register will give the instruction to accumulator register, which is the and then after that, when the output after the CPU process the instruction, the output will be given back by the accumulator register, and then the data register will receive it and then pass it to the I/O module. Okay, so in the I/O technique, each instruction produces a single input or output. Okay, so the address information must be sent with the IO instruction to recognize the IO device's individual. Okay, so whenever it sends some instruction, the address also sent together with these instructions, with the instructions, so that the the CPU will recognize which IO devices send the instructions. So after that, a full instruction, which is the fetch execute cycle for each IO data word, it will be very slow because um, when one cycle finish, then baru the other cycle can start. Okay, so it didn't it is very macam time consuming lah. Okay, so the example of it is the keyboard. When we use the keyboards, when we click one keyboard or yeah keyboard lah on our keyboard, then it will go through the process of program our technique lah. So this is the example of process that happen when we in the program IO technique. So, for example, when our CPU execute input 24, so it is actually some machine learning, sorry, machine learning, some instructions, maybe in a code lab, if I'm not mistaken, maybe this is the assembly language lah. So there's the input 24 instructions. So when CPU execute these instructions, 24 is actually the address of the memory. So this address will be copied to the address register. So this is the address register. Okay, so that is will happen when CPU execute input 24. Meaning address 24 will be copied to the address register. After that, address 24 will be recognized as the keyboard by the keyboard IO. So, assuming that this IO module is the IO module for keyboard. Okay, so there's a part in the IO module which is the read and write control line will indicate that the instruction will be input. Okay, so in this part, in the IO module part, it will indicates the instruction is as an input. So after that, a buffer in the IO modules, there's a buffer here. Okay, it will hold the keystroke. Okay, so in this case, it is the ASCII at the end, 68, and then the ASCII 68 is actually a letter D. Then the data, once the IO modules know that, once it know that it's D, then the data will be transferred to the IO data register. After that, from the IO data register, it will be copied to the appropriate accumulator or general purpose register to complete the operations. Okay, so this will be saved in the memory after it knows that D is actually is like 60M. Okay, so we proceed to the interrupt methods or technique. Okay, so we remember that the program IO, it only when one's process is finished, then baru the other process can take place. Okay, so it is very time consuming. So that's why the interrupts technique is created. Okay, so this interrupt technique, um, it is where a signal that cause the CPU to alter its normal flow on instruction executions. Okay, so Interrupts is actually the signal. Okay, so it is the electronic signal that causes the CPU to stop its normal flow it stop its current processing, and then it makes the CPU start the other process, which is the interrupts process lah. So these interrupts will free the CPU from waiting for events, and then it provides control for external input. Okay, so this is the list of example of interrupt that can interrupt the process of the CPU. For example, the unexpected user input. Okay, when you are copying, tiba-tiba you want to open the Microsoft Word, then it can stop the process of copying sekejap saja. Okay. Okay, so another example is illegal instructions. After that, multitasking or multiprocessing of your computer, or maybe abnormal situations. Okay, so before we learn further about the interrupt, so we need to know what is the interrupt lines and then the interrupt terms. Okay, so what is the interrupt line? Interrupt line is a special control to the CPU that provide the interrupt capabilities. Just imagine that it has macam physical line lah. Okay, so just imagine the interrupt line is a physical line. Macam in the highway, if you know there's in the highway, in the road highway, there's an emergency line kan. Okay, so just imagine that the special control line is like the emergency line. Sorry, emergency lane of the road. Okay, so it is like a line or just a physical line to CPU to provide interrupt capabilities, meaning the only things that can go through that line is the interrupt signal. Okay, so the message that's sent to the computer on this line or this interrupt line known as interrupts, meaning only interrupts that can go through the special or go through the interrupt line. For example, if the in the apa tu highway only emergency cases like maybe ambulance that can go through that emergency lane kan. So just imagine that interrupts is like the ambulance, and then the interrupt line is like your emergency lane in the highway. Okay, so these interrupts will cause the computer to suspend the program being executed and jump to a special interrupt processing program. Okay, so that interrupts, which is the message or the ambulance, can cause the computer to suspend the program that is being executed, and it will jump to the special interrupt processing program. Okay, so during servicing the interrupt, this is what happened. First, CPU will, when it receives an interrupt, it will suspend the program in progress. After that, it will save all of the information of the current program in progress, including the last instructions executed, and then the data values in the register. It will save all of that info inside a part of memory we called as PCB or process control block. There's a part in the memory that called as a PCB that will hold the information about the current program that is in progress that is suspended by the CPU. And then it will go to the interrupt handler program. The interrupt handler program is the interrupt that is, it is the new address, it is the new address, the new instruction that interrupts the current processor. Okay, so we call it as interrupt handler program. After the CPU set all of the current informations or the current program in the PCB, it will serve the interrupt handler program, which is the new program that interrupt the process lah. Okay, so this is what happened when interrupts happen in the CPU. Okay, so before the interrupt arrives, program A is executed in the memory. Okay, so why we know that the program A is executing is by the program counter in the register, because we know that it is the current program executed or executing, because the PC or the program counter is pointing to program A, meaning it is the current program that is executing by the CPU lah. After that, this is before the interrupts arrives lah. Okay, so after the interrupt arrive or received by the CPU, all of the information of the program A will be stored in a stack area, or we know also known as process control block. Okay, so all of the current process that interrupted will be stored in a stack area. And then the program counter will be loaded with the starting location of the program B or the interrupt handler program. So that's why I said the interrupt handler program is the new program that interrupting the current progressing program lah, or program A. Because after that, this caused the PC jump to program B, which is become the executing program. Okay, so whichever memory that is pointing out by the PC, it will become the executing program. Okay, so when the interrupt routine is complete, when the program B is completed, and then all of the information in the stack is restored again, and then the PC now will be the PC now will be pointing again to the stack area, okay, to the previous information that is stored in the stack area. Okay, so this is the use of interrupts. There are few use of this interrupt. First, it is as an external event notifier. Okay, so the interrupts is notifying the CPU of external event that require actions, and then it makes the CPU free from polling. Polling is actually waiting. Polling is like the process of waiting, because in the program I/O, the CPU will be waiting until the process completed in one fetch cycle, kan? But using the interrupts, it will make the CPU have no waiting time. Okay, so that's why it is this interrupts technique is better than the program I/O, because it faster, because the CPU is free from polling. And then this interrupt it user to control the computer from the input device. This interrupts technique enable the user to control the computer from the input device. For example, when user input something lah in your computer, or real-time system or real-time sensitive system. Real-time system is like, for example, if you have a software that is actually running or can give interaction without any interactions from user. For example, if you have a map, and then the map is showing some data, and then the data is actually real-time data, meaning every time there are new data, the map will automatically show the data without any interruptions from user, or without user triggering or clicking any button lah. So that is the real-time system. Okay, so another use of interrupts is as it is used as a completion signal. This is because the interrupts control the flow of the data to the output device, and then it also notifies the computer of the completion of a particular course of action. Okay, so the example is when printer ready, printer to control the flow of the character to the printer in the efficient way. Okay, so wait, okay, so completion, the interrupt as a completion signal. Okay, so for example, when the printer ready, that printer will control the flow of the character to the printer in an efficient way. Meaning, the printer when it is ready, it the printer will control whatever action that it wants the CPU take after that. Okay, so the third use of the interrupt is the interrupt as a means of allocation CPU time. So allocating CPU time to different programs that are sharing the CPU. Okay, so for example, the time sharing. Okay, so since the CPU can only execute one program at a time, so the computer system share the CPU by allocating small segment of time to each program in rapid rotations among them. Okay, so for now we will only know this by theory because we don't have example of later on, when I find an example for this, I will share with you guys. But if not, then um, just imagine lah this thing. Huh? Okay, so after that, the another use of interrupt is it is act as an abnormal event indicator. Okay, so it will tell the computer when there's an abnormal event indicator. Okay, so interrupts can handle abnormal event that affect the operation of the computer, and then its usage is similar to the external input event, but in this case, the event are directed at the problem within the computer system itself. Okay, so for example, is the power failure or illegal instruction or some hardware error. Okay, so software interrupt. Software interrupt is one of the interrupt that can be set or can cause the interrupt technique will happen. Okay. Um, so this software interrupt is generated by operating system, and then the interrupt instructions works in the same way as the hardware interrupt. It will set the appropriate register and transferring control to an interrupt handling procedure. Okay, so it works same like the previous interrupt, which it will save all of the info of the current processing program to a part of register that called as PCB, if you remember the interrupt process previously. But the only difference is the trigger of the interrupts are not from the hardware. but it is from the software, which is generated by operating system. Okay, so the example if the handling timer expiration and exception handler. Okay, so this is the exception handler is whenever the um, the software run any try catch exception. I think you all know about the try catch exception lah, because this is usually happen when you code error handling in any of your code. So if your software um, have this try catch and exception, then it can makes the CPU operate. I mean, it can interrupt the CPU lah, but it is usually generated by operating system because operating system is connecting the software to the CPU. Okay, so how will the CPU manage the multiple interrupts? So when there are interrupts occur, are there other interrupts already waiting service? Actually, what do you think? If an interrupt occur, do you think there are any other interrupts is waiting? Noel,
What's the question again?
the question is when an interrupts occur to a CPU, do you think there are any other process of interrupt waiting?
Yeah.
Hmm. Okay, so yes, actually, when there's an interrupt, actually there are a lot of process or program that are waiting to interrupt the CPU. Okay, so how CPU will handle this when there's a lot of interrupts? So it will prioritize the interrupts. Okay, so the CPU will prioritize each of the interrupt so that it will serve the top priority interrupt first. Okay, so these are the method of how the CPU will identify or the method of how the CPU will prioritize the interrupt. Okay, so there are two methods of how CPU can prioritize the interrupt, which is the first is vector interrupt, and then the second is default interrupt. Okay, so for the vector interrupt, the address of the interrupting devices is included as part of the interrupt. So meaning the address of the devices will be included in the instruction. When the I/O module send the instruction to CPU, the address of the device also will be brought together or sent together to the CPU. For the code interrupt, the general interrupt that's shared by all devices. This code interrupt is the general interrupt that's shared by all devices, and then it identifies the interrupting device by pulling each device. Pulling is actually waiting macam first come first serve. Okay, so this polling interrupt is shared by all of the devices that are waiting to be to waiting to interrupt the CPU, and then it's like it will identify the interrupting device by pulling each device. Okay, pulling each device meaning waiting each device. Okay, we will see in the next diagram. Okay, so this is the showing the process of the vector interrupt. Okay, so let's say there's a memory here. So there are a lot of process that's still going, still processing. Okay, so let's say there's interrupt can occur, and then the address of the interrupt, and each of the process will have its address. Okay, so if you see each of the interrupts on the process have its address. Okay, so let's say interrupt can occur. So when interrupt can occur, and then you see here in the interrupt, it also containing its address, and then um, when it's occur, it will jump to care service routine. Okay, so this care service routine, this care service routine, hmm, sorry, this is a full interrupt. Okay, so this is jump to care service routine. Wait, guys. Okay, so for this, I think this is um, the next process when a process is okay guys, I will get back to this process vector interrupt processing. I will give you the details tomorrow. Vector interrupt processing. Okay, so the same with the pole interrupt processing lah. Okay, because this diagram is not detailed, so I also cannot say much about this. Okay, so pole interrupt processing also, and then the multiple interrupts. Oh, pasti a question terus. Okay, so vector and pole interrupt processing. Hopefully, I can find few or video about this. Okay, so multiple interrupt. This also will be tomorrow. Ask your questions. Okay, so now DMA. Okay, so multiple interrupt also lah. Multiple interrupt. And spatial questions. Yeah, because tomorrow I also plan to use the tutorial time to try to discuss about spatial questions lah. So this is also will be on tomorrow. Will be discussed on tomorrow. Okay. Okay. So after that, so I owe you three small topic, which is the vector in interrupt processing, called interrupt processing, and multiple interrupts. Okay, so we proceed to do DMA lah. Okay, so now it is enough for you to know that when there are three techniques of exchanging informations, or the way of the CPU and I/O device communicating, which is program I/O, interrupt, and DMA. In the interrupt, um, there are They are hardware interrupt, and then the software interrupt, and then after that, when there are multiple interrupts happen, there will be a prioritizations process. So how the CPU will prioritize the interrupts are by vectored interrupt, pulled interrupt, and then multiple interrupt lah. But this multiple interrupt prioritization we will cover again tomorrow. And now we proceed to DMA. Okay, so DMA is the method of transferring data between peripherals memory without using CPU. Okay, so like I said just now lah, the peripheral devices or the I/O module directly go to memory without going through the CPU, and it can transfer large blocks of data. So it will direct transfer, and then the CPU will not actively involve itself. Okay, so but there are conditions for the MA to occur. It cannot be happen easily lah. Okay, so there will be a condition. The first condition is the I/O interface and memory must be connected. And then the I/O module must be capable of read and write to memory. Okay, so meaning to say that your I/O module must support or have the capability to read and write to the memory. And then the conflict between the CPU and the I/O module must be avoided. Okay, so after that, the transfer is initiated by a program in the CPU. First, in the DMA, what happened is the transfer will be initiated by a program in the CPU lah. But it will be using the program I/O, but the CPU can then bypass for the remainder of the transfer. Okay, the process is started by the CPU, but the remainder of the transfer will be only done by the I/O module and the memory to the memory directly lah. Okay, so the I/O module will notify the CPU when an interrupt when the transfer is completed. Okay, so the CPU only will be disturbed after the transfer is completed. Okay, so once this has occurred, the data in the memory will be ready for the CPU to use or the program to use. Okay, so the example of the MA is such as when we have a program that sorts a block of number. Okay, so when we have a program that only sorts a block of number. Okay, so to operate efficiently, the I/O will transfer the entire block of numbers from HDD to memory. HDD is your data tu lah, bukan external data, your internal data also, but it is in HDD. Memory is the RAM lah. Okay, so it will transfer the entire block of number from HDD to memory. After that, the sorting will be happen in the memory. After that, the data will be transferred back to the HDD. So this happen without without involvement of CPU. Okay, so but for the DMA to take place, the three primary conditions must be met. Okay, so the condition that must be met is there must be a method to connect together the I/O interface and the memory. Meaning this is the physical connection. Meaning to say that your hardware, the I/O module too, it is like a one hardware, and it must connect the I/O module with the memory. There's the connection between them. So just imagine, maybe you can search the internet, the IO module. There's a lot of actually the IO module. It is um, it is based on what devices that you want that is served by the IO module. Okay, so you guys can see here lah. This is the example of IO module lah. Okay, so this is based on each of these IO module is serving some kind of peripheral device or input output devices. Okay, so for DMA to happen, there must be a connection between the memory and your IO devices or IO interface that is inside your IO module. Okay, so in some system, both are already connected to the same bus. So this requirement is easily met. Okay, so usually the modern hardware or modern hardware lah. So it is already have or it is already connected in the same bus. But for the older versions, maybe no lah. So the second condition to use the direct memory access is the IO module associated with particular device must be capable to reading and writing to memory. Okay, so your IO module should have the capability or should support the read and write to the memory. Meaning, if you want to buy any of these, you need to know either it can directly read and write from memory. Okay, so it does so by stimulating the CPU interface with the memory. Okay, so for the IO module to have the capability of reading and writing to the memory, it will simulate the CPU interface with the memory. Okay, so specifically, the IO module must be able to load a memory address register and to read and write to a memory data register. Okay, so what does it mean by stimulating the CPU interface with the memory is your IO module must able to load the memory address register and to read and write to a memory data register. Okay, so it means that your IO module must have this capability, which is load a memory address register and read and write to a data register. Meaning it can take whatever the CPU can able to do, and then your IO module also must have that capability, so that it doesn't need the CPU help because it can directly communicating with memory as long as it can simulate the responsibility of the CPU in your IO module. Okay, so the third condition for the DMA is there must be a mean to avoid conflict between the CPU and the IO module. Okay, so it is not possible for the CPU and a module controlling this IO to load different address to the memory address register at the same instant, or for two different IO modules to transfer data between IO and memory on the same bus at the same instance. Okay, so there will be a conflict because the IO module, if it has the responsibility the same as the CPU, there will be a conflict lah. And your IO module must be able to handle this kind of conflict. It should have some um, some way of handling the conflict between the CPU and the I/O module lah. Okay, so since the CPU is not actively involved during the transfer, the CPU can be used to perform other tasks during the time when input-output transfer are taking place. Okay, so when the transfer happen between I/O module and the memory, so the CPU can do another task. Okay, so DMA is not limited to just this to memory transfer. It can be used with other high-speed devices. Okay, so the example that is given previously, it is from HDD to memory kan, but this technique also can be used by high-speed devices to memory. Okay, so DMA is an effective mean to transfer video data from memory to the video I/O system for rapid display. Okay, so DMA can be usually used for to transfer video data. Okay, so there are four pieces of data that must be provided to initiate the DMA transfer. Okay, so the first data is the location of the data on the I/O device. Okay, so in order to do or to initiate the transfer using DMA technique, there are four informations that is needed. Informations or data lah. First is the location of the data on the I/O device. And then the second is the starting locations of the block of data in the memory, meaning where you want to, or the address of the location that you want the data to be saved later in the memory. And then the size of the block to be transferred, the size of the data from the I/O device that you want to transfer to the memory, and then the directions of the transfer. Either it is from I/O, either it is from your I/O module to the memory or from the memory to I/O module lah. Okay, so this is the how the process of the initiations between in the DMA and how it can be controlled. Okay, so the first program I/O used to prepare I/O module to transfer by providing required informations by initiating transfer. Okay, so meaning to say that the CPU will give I/O instructions to the I/O module by giving the memory address, the disk address, the size of the block, or the directions of the transfer, either it is read or write. Okay, so after that, the DMA it can take place. Once it has all of this information, DMF transfer can take place. Okay, so in this case, maybe the instruction here is to transfer the data from this to the memory. From this to the memory, meaning read lah. Okay, so the instruction here maybe in this case is the read. Okay, so after that, after the CPU will give the instruction to the I/O module. Remember, DMA is initiated by CPU. Just remember the first fact just now. DMA will be initiated by CPU. Okay, so in this case, it is initiated by CPU give all this information to IO module. And then because the IO module already have all of this process, all of this information, then DMA can occur. So in this case, based on the instruction from the CPU, DMA can occur by reading from I off the memory. Okay. By read data is transferred from disk to memory. Okay, from disk to the memory, meaning the computer is reading the information from the HDD. Okay, so after that, upon the completion, the disk controller will send completion interrupt to the CPU. After all of the data transfer completed, barulah the HDD will send interrupt to the CPU telling that the process is already completed. Okay, so it takes several instructions to initiate a DNA transfer. Okay, thus, it is not useful to perform a DNA transfer for very small amount of data. Okay, so if the data to transfer is small or a computer only performs single task, the time freed up by DNA cannot be used productively. Okay, so that's why DMA is more useful to transfer a video because video data is a lot lah. It takes a huge size in the memory, so that's why DMA is more suitable for the data like video. Okay, so CPU memory I/O architecture. Beta. Okay, so before we proceed, are you guys still there? Hello, Farah, are you
Oh yeah.
still there? Okay,
Yeah.
Sino still there? Okay, Kelvin said very boring. Yes, it is boring because it is theory and we cannot see any moving items here, but it is a theory, kan? So after that, a CPU memory architecture beta. I am not sure either we should cover it today because too much information at one time will explode.
This one got like calculation.
Macam no. Only yang interrupt just now lah. It has, tapi it is a very minimal punya calculations.
I
It is,
see. Okay.
it is not like a previous chapter that needs you to do a lot of technical things kan. Okay, so this is just a more on theory lah punya apa tu chapter. Okay, so this is bus configuration, bus architecture. I think we can cover this today lah because it is not a lot of technical things. And we still have 1 hour, so we should not waste our time lah kan. Okay. If you guys don't understand, maybe you need to read it again later lah because for the theory things to melekat to your brain, you need to read it again and again and again. Baru boleh ingat.
Miss.
Yes.
If for the final the exam, will there be any theory involved?
Ada, tapi sikit.
Oh, I
Yeah,
see.
so I need to exam because I haven't opened the example of the past year questions because I just received it this morning. So I haven't have time to open it yet. So later we will see lah. Hopefully tomorrow and next week we can focus more on how to answer final year bukan FOA
Okay.
questions. Okay, so we proceed to the CPU and memory input-output architecture. Okay, so before we proceed to this, I just want to repeat again what we have learned previously in this chapter. Okay, so previously we have learned about two main subtopic, which is what is the I/O modules. Okay, so as the summary, I/O module is the middleman that is that is um, between CPU and I/O module. So it receives the instructions from CPU and it will send the info to I/O module. So that is it will send the info to the I/O devices or peripherals. So that is the I/O modules. And then there are three types of how I/O peripherals or I/O devices interacting with CPU. So there are three technique or method of the communicating or exchanging the info between CPU and I/O module. I/O devices, which is program I/O, interrupts, and direct memory access or DMA. Program I/O is the basic way, but it takes time because it need to complete one proses baru it can take another baru it can run another request or instruction, so it takes time, and then it is enhance or improve. The problem in the I program IO is improved by the interrupt technique, which while the CPU polling for the first process to complete, it can do another task or another CPU we can do another task while waiting for the first task to complete. So that is in the interrupt. Okay, so in the interrupt, we have learned how what is happening during the interrupts. Okay, so if you remember the common or the current information of the program A, which is the current program that is run by the CPU will be stored in the in the part of a memory, and then after that it will serve the program B or the interrupts. After the interrupts completed, and then the program counter will loaded again by the info that is saved to the PCB previously. Okay, so that is happen in the servicing interrupts lah. Okay, so we have learned about three uses of the interrupts. After that, we have learned the multiple interrupts and prioritization. But I owe you this topic because it has the vector interrupt processing, fold interrupt processing, and multiple interrupt. But this topic is about how the CPU will prioritize which interrupt can be or should be served first. So after that, we have learned about DMA. So this DMA is actually better, but it is not suitable for all kind of data. It is only suitable for data that is a very large data like video data. Okay, so DMA is macam it is better because it didn't disturb the CPU, because CPU only used to initiate the process, but it didn't involve when the process between memory and the I/O happening. So it actually good lah because it didn't kacau the CPU, but it only suitable for video type of data. Okay, so now we are proceed to the system architecture. So this is the architecture of the I/O input-output system. So okay, so there will be two two architecture that we will learn, which is the I/O bus architecture and the channel architecture. Okay, so I/O system architecture can be divided can be categorized by two, which is the I/O bus architecture and channel architecture. Okay, so this is the first architecture, which is the basic CPU memory I/O, meaning this is the basic architecture of how I/O module is connected with the CPU lah. Okay, so as explained previously, I/O module is the middleman between CPU and I/O device. But um, for the program I/O, it doesn't need memory because it is solely between I/O module and the CPU. But for the interrupt and DMA technique, it uses memory. Okay, so this is the basic of architecture of input-output system. There should be a CPU, there should be I/O module, there should be I/O devices, and then um, there should be a memory for interrupt, for the DMA and the interrupt driven technique lah. It should be a memory, but for the program I/O technique, uh, the memory is not necessary. Okay, so okay, sorry, this is the basic lah, the basic system of I/O, and then this is the two architecture that is introduced by the expert lah, which is the bus architecture and the channel architecture. Okay, so this bus architecture is used in almost all personal computer. And then for the channel architecture, it is found in the IBM mainframe computer. Okay, so the IBM mainframe computer is the largest computer in the world lah. Okay, so this bus architecture, it has the backbone for connection of various component, memory and I/O to the CPU. Okay, so the simplest form will connect the simplest form of this system bus will connect the CPU to the memory and to all the various I/O module that control the I/O device. Okay, so this is like what this diagram lah. This is the simplest architecture. Okay, so it connect the CPU to the memory and to all the I/O module that control the I/O device. Usually, one I/O device will have one I/O module lah. Okay, so this bus architecture, it consists of a number of interconnected bus. Okay, so like the CPU bus, PCI bus, and ISA bus. Okay, so these buses are interconnected by bus interface. Okay, so this bus interface is actually the expansion bus interface or bus bridges. This bus interface expand the flexibility by converting by bus signal from one to another. So the main responsibility of this bus interface is to convert the bus signal from one to another. And then the interconnect ability makes it possible to design and use industry standard bus on equipment of different vendor. Okay, so connection of I/O devices standardized across a wide range of equipment types and manufacturers. Okay, so the major aspect of open architecture concept. Okay, so this bus architecture, because it is used by almost all of the personal computer in the world, so it use the open architecture concept, meaning um, it is the architecture that is widely used, and then all of the manufacturer should use that standard architecture so that it can be widely used by any type of computer lah. So this is the bus configurations. In the to connect CPU with the memory and then the other I/O module, it use CPU bus or it use the CPU bus, and then bus bridges or bus interface is used for connecting the CPU bus with the special bus, because this special bus and the CPU bus cannot connect directly, so it needs some interface. This interface will this is what this means lah, because this bus interface can convert bus signal from one to another. So that's why CPU bus needs this bus interface, because to connect special bus with the CPU bus, the bus interface must convert the signal to suit each other. Okay. Okay, so maybe there are some I/O module that needs special treatment lah. So that's why it needs the bus interface. But maybe there are common I/O devices that doesn't need the bus interface, so it can directly connect through the CPU bus. Okay, so the channel architecture, which is the architecture or bus architecture that is used by IBM. Okay, so it is used in all IBM mainframe computers since late 70s, and then it has channel subsystem. This channel subsystem separate the I/O processor that serves as a separate CPU for I/O operations, and it can channel the control words, and then the program stored in the memory, it is independent of CPU, meaning it doesn't need to when the program stored in the CPU, it doesn't need help of the CPU. It doesn't need to depend on the CPU, and then transfer data between memory and I/O device using DMA. Okay, so that's why the IBM is uses DMA technique because it doesn't need CPU lah. Okay, actually it needs because but it not fully depending on the CPU, because CPU only initiate the transfer. Okay, so there's also this channel architecture also have sub channel. So this sub channel is connected to a control unit module through one or more channel path. A similar role to a device controller. So this subchannel has a similar role to a device controller. Okay, so they are up to 8 different channel path between the channel subsystem and control unit. Okay, so this control unit will be used as alternative if the other channel subsystem is busy. Okay, so this is the architecture of the channel architecture. So CPU connected to the memory, and then like inform or described previously. There's the channel subsystem, and then there's also control unit, subchannel. Okay, so this is the channel subsystem. Channel subsystem. Okay, so channel subsystem will separate I/O processor that serve as a separate CPU for I/O operations. So this is control unit. So imagine that there's a lot of devices, and then the control unit is like the I/O module. Then this channel subsystem will control all of this control unit, and then the control unit is connected with the channel subsystem through channel path. Okay, so that is all about this chapter lah. Okay, so as a summary, we have learned about I/O module, program the technique to communicate between I/O devices with the CPU. There are three, and then just now we have covered the I/O system architecture. We have learned two architecture. First is the basic architecture, which is used by all of the personal computer in the world. And then the second architecture is the channel architecture. It is used by IBM, and then it used DMA technique. The I/O bus architecture usually used by personal computer, and it usually use the technique interrupt driven, this interrupt I/O driven technique. Okay, so do you have any questions?
Okay, finish already.
Yeah, finish already.
Oh,
59.
so far no.
Okay. So this is the first time we have finished our class. I think this is the second time lah. And previously we also finished earlier, but we have no video now. Might not manage to get everything in my head. Yeah, of course. Me also, if I didn't read it again and again, and I also cannot remember it. Okay, so if you guys have no questions, I will upload the tutorial about this chapter in our Google Classroom, and then we need to discuss it tomorrow lah.
Okay.
Okay. Okay. So I will inform you guys in the WhatsApp group if I already uploaded the tutorial. Okay. So guys, if you don't have any question, then we can dismiss lah.
Okay, Miss.
Wait. I saw some Noel said, yeah, will be better if there is a practice for better understanding. Yeah, but this is architecture kan. It means that we need to open up the computer to see the architecture lah, kan?
No.
Yeah.
Yeah. But unfortunately, we are not in our lab.
I mean
I
like
don't know.
exam
I don't know
question.
if we have if we are learning face to face. I don't know if this really need us to open up a computer. Yes. I heard someone is talking just now.
The practice, I mean like the exam question. To like
Oh,
like that.
okay. I think the tutorial maybe can give some. We will see the tutorial first. I have a glance of it just now. Hmm, nah, this one. So later you do this lah.
Okay, Miss.
Okay. You can see here it is just um, kan. So the questions is the theoretical lah. Okay, so you see this letter lah. Okay. Bye guys.
Okay,
Okay, Miss.
thanks.
Thank you.
Okay, bye.